Welcome student to the next lecture of halogen derivative. This is lecture number 6 and today we are going to study about chemical properties of alkyl halide. And in this today we'll be studying about substitution reaction. And in substitution reaction, normally we'll be studying about nucleophilic substitution reaction. Now, what is this nucleophilic substitution reaction, or what is the substitution reaction? Let's understand. Suppose in general I take Rx. What is Rx? It's alkyl halide. And I treat this with some nucleophile. Nucleophile, you know student, what is nucleophile? Nucleophile means nucleus loving. So nucleus means positive. That means they are that reagent which is going to attack on a positive part. So this is negative. Since it is negative, it will like to go and attack on a positive part of a substrate. This is substrate. Understand? This is substrate and this is a nucleophile. Nucleophile is going to attack on the substrate. Okay, and when it attack, it's remove this X. I write the reaction. X is removed, we get Y, and I get X minus. That means in this reaction, what happened? Nucleophile has substituted X, that is halogen, to form Ry. This is what we call nucleophilic substitution reaction. Understood? Understood student? Simple. Now we'll be studying few examples of nucleophilic substitution reaction. In that, first one is where formation of alcohol takes place. Formation of alcohol. Okay, in this, let's see the reaction. We take alkyl halide Rx, and this alkyl halide is treated with aqueous KOH or NaOH. Suppose I take aqueous KOH. I hate this, right? What will happen? Now student, let's understand. See, we know alkyl halide. In alkyl halide, R is positive and X minus is negative, right? Understand? See, there's a bond. This bonded pair of electrons shift towards where? Halogen. So it acquires partially negative charges, partially positive charge. Okay, actually this is also a nucleophile. Okay, and here when this alkyl halide is attached with what? Is attacked with what? KOH. Okay, so what happened? Here it results in the formation of R. X is replaced by OH, ROH plus KX. It results in the formation of alcohol. Okay, we'll take example and then try to understand some mechanism of this. Okay, suppose I take ethyl CH3I, ethyl iodide. I treat this with KOH. Condition remains same. What will happen? CH3OH plus Ki is formed. What is formed? Ki. And another example, C2H5 C2H5, let's say take Br. This is ethyl bromine. This time I treat this with NaOH. It will result in the formation of C2H5OH, that is ethyl alcohol, plus NaBr. Okay, so that's a simple reaction. Now student, we'll be understanding the mechanism in great detail when we study SN1 and SN2 reaction. Okay, but for time being, to make the things bit understandable, so that the other reaction which come further, to make that simple, we'll understand here somewhat. Okay, now let's see. I have taken CHHH, and here suppose I have I. Okay, when KOH is put into the water, hydrolysis take place. The reaction is what? Hydrolysis. Okay, so when I put this into water, it results in the formation of K plus and OH minus. Now student, K plus, Na plus, they are stable, right? Because their octet is complete. Since their octet is complete, they are stable. They're not going to do anything. They have a simple life and they are happy in their own life. But here OH minus has acquired negative charge. Okay, since it was acquired negative charge, it is getting that burden of that 2 electrons which was given by K plus. So the life is not that simple for OH minus. Okay, so he wants to get rid of that electron which is making his life miserable. So for that reason, what he's going to do, this OH minus is going to give its electron to someone who can take its electron. Since it is negative, it will be searching for someone who is positive, because positive can take negative electrons. So sorry, if you look for this, carbon and hydrogen, their electronegativity is almost same, right? So nobody is going to there's no polarity in this. But when I say carbon and iodine is electronegative, or if I take chlorine or fluorine, they're electronegative in nature. So being electronegative in nature, it tends to pull the electron, bonded pair of electron, to itself. As the shifting of electron take place over here, this iodine acquire partial negative charge and this carbon acquire partial positive charge, right? That means in this substrate, this carbon is positive and this I minus is negative, right? So this OH minus will come to this carbon. Now this OH minus can come to carbon in from here also, in front, from backward also. But OH minus is negative, I minus is negative. When they come here, there will be repulsion. And understand, student, and remember this: whenever there is a repulsion, energy will increase. When energy increases, stability decreases. So it wants to avoid that, and that's the reason OH minus approaches this carbon from backside. Okay, so this OH minus will approach to this carbon from here, OH minus, and it tends to put its electron to this carbon. As the carbon is getting the electron from here, it will give electron to iodine, and this is how this bond is going to break and this OH minus comes in, right? This is how this iodine is substituted by OH minus. Since OH minus is nucleophile, that's why it is called nucleophilic substitution reaction, and we do understand the product will be CH3OH, and this I minus comes out and will remain as what? I minus. I hope this is clear, and this is going to happen in rest of other reactions also when we studied substitution reaction. There's another part of the reaction, it is elimination. The things will be different over there, right? But coming today's, I think, whole lecture, we'll see this type of reaction. Only the things that you have to identify which is a nucleophile in a given reagent, right? Substrate, reagent. In a reagent, you have to identify nucleophile, and where this nucleophile is going to attack, that is what you have to find, student. Okay, ready? Let's start with the next reaction, and this mechanism is going to be same for rest of the reaction. If I feel there's a need to explain, I'll be explaining, otherwise the things is going to be same. Let's take one more example where the reaction take place with moist Ag2O. Ag2O is silver oxide. What is this Ag2O? It's nothing but silver oxide, student. Now what happened? This Ag2O, visible, yes. This Ag2O, it reacts with water, that is HOH. I can take it twice. Okay. Now what happened? This 2Ag will combine with, see, when I say moist Ag2O, that means water is also present. So when water is present, this Ag2O will combine with this water and it result in the formation of 2Ag will combine with 2OH to 2AgOH, right? Okay, and this hydrogen is going to combine with oxygen to form what? H2O. Okay, now when reaction take place with alkyl halide Rx, treated with what? Treated with AgOH. AgOH. Now student, in this AgOH, OH minus will act as a nucleophile. This is going to attack to this R. X will be removed. OH will come. Again it form ROH. That is nothing but alcohol. Plus AgX. I read one example. Suppose I take C2H5Cl, ethyl chloride. I treat this AgOH. But understand this AgOH is nothing but moist silver oxide. Right, I can write here on the arrow moist Ag2O, and I hate this. This is what we have tried during the exam. Okay, so C2H5OH will be formed, that is ethyl alcohol, plus Ag is going to combine with Cl to form what? AgCl. Right? So in this way we form alcohol. Right? Now moving to the next reaction. Now, next reaction is formation of alkyl cyanide. Formation of alkyl cyanide. Okay, now what this reaction is, let's understand in the general form first. Rx, alkyl halide, is treated with KCN, and this KCN is alcoholic KCN, and we hate this or boil this. Okay, now again understand student, when I put this KCN in alcohol, KCN has actually KCN is an ionic compound, so it is going to dissociate as K plus and Cn minus, right? Understood. Now, so this will acquire K plus and this Cn minus, and this negative charge is on the carbon, right? This negative charge is in carbon and this will become what? Plus. So this Cn minus will attack from backside, and this X here Cn minus attack, and this X will move out. So it results in the formation of RCN, alkyl cyanide, plus KX, right? Take one example. I take suppose CH3 methyl iodide. I treat this with KCN, alcoholic, boil this, CH3CN methyl cyanide, and Ki. Okay student, now here one thing, this Cn minus student, if I write here Cn minus, this Cn minus is actually ambident. What is ambident? Ambident means it has two possibilities to attack. Here nitrogen also have a lone pair of electron, and this lone pair of electron can also attract the substrate. Here carbon has negative charge, it is also rich in electron, even it can attack. Now the question is, why carbon attacks and not the nitrogen? See, nitrogen is electronegative. Being electronegative in nature, it has a tendency to keep its electron to itself. That electron is going to stabilize him. But this carbon, we know carbon is not that much electronegative. Since it is not that much electronegative, to hold that electron to itself is a big difficult task for him. That's the reason this carbon wants to get devoid of this electron, and that's the reason it is going to pull this electron to someone else's house, right? So whom is going to put this electron? This carbon is going to put the electron in the orbital of this alkyl group, right? Nitrogen can hold that electron, right? It is not going to make nitrogen so unstable, but this electron is going to increase the instability on this carbon, right? So this electron which is in the head of carbon, he wants to get rid of that, right? And that's the reason carbon is going to attack, not the nitrogen. Okay, got that, student? Right. So it results in the formation of what? Methyl cyanide. Moving to the next part is formation of alkyl isocyanide. Formation of alkyl isocyanide, and that's the important one. Let's understand. Suppose I take CH3Cl. I take example first, and I treat this time AgCN. And when I say CN, right, student, there's a carbon and nitrogen, there's a triple bond. Okay, understand this point, right? We all understand nitrogen has a lone pair of electron, and there is a covalent bond between this Ag and carbon. It's not ionic bond like KCN. Understand that. Here the difference lies. Now, AgCN is a covalently bonded. Result, this electron Ag is not going to give its bonded pair of electron to carbon, right? Not so simple to give that. Okay, but nitrogen has this electron, and this nitrogen is not going to wait so that there's a dissociation between Ag and carbon and this electron is going to come on carbon. Nitrogen is not going to wait for that much. As a result, this nitrogen is going to take the lead. This nitrogen is going to put the electron to this carbon. It is not going to wait for this carbon to put the electron. So when nitrogen comes, right, and this nitrogen gives the electron, chlorine gets the electron from this carbon, chlorine moves away, nitrogen comes in, right, and the bond form will be between nitrogen and carbon. As a result, it will form CH3NC. What is going to form? CH3NC, and NC is isocyanide. Okay, so what is formed? Methyl isocyanide is obtained. I hope you understand the mechanism of this, right? So that should be clear in your mind why this happens, right, student? But that, okay. Now moving further, next one is formation of 1 degree amine. The process is also called as aminolysis. Okay, now what happened in this reaction? Let's understand. Suppose I have alkyl halide, that is Rx. I treat this with ammonia. What is the formula of ammonia, student? Ammonia is NH3. What is the formula? NH3. Can I write like this? H2NH. Can I write like this? Yes, I can, and so I'm writing that. Now RxNH2, nitrogen has a lone pair of electron. It has lone pair of electron. It will have tendency to attack on alkyl group, and it will attack. Since this is going to attack on this X will come out, and this X is going to combine with this hydrogen to form halo acid, that is HX, right? Means in short, this NH2 minus will act as nucleophile, student. This is what you have to identify, right? So this nucleophile is going to attack on this carbon, this X is going to come out, this X and this hydrogen are going to combine, and what will be formed? It will, and one more thing, this will be alcoholic heating under some pressure, right? So some pressure will be there. Okay, student. So what will form? RNH2. RNH2 is nothing but primary amine, that is 1 degree amine, and HX. Let's write one example. I take C2H5Cl, ethyl chloride, treat with this ammonia. Again I write like this, H2H, C2H5 condition is going to remain same. I'm not writing condition again and again. C2H5 will combine with this NH2, it will form ethyl amine plus HCl. Okay, student. Okay, so it results in the formation of what? Ethyl amine. Okay, got that? Right. Now, moving to the next lecture. Sorry, not next lecture, next reaction. Next reaction is, I think you have studied this in 11th. If not, we'll study now, don't worry. Next is formation of ether. Formation of ether. It is also called as Williamson synthesis. Williamson synthesis. Okay, now let's understand what is this reaction. In this reaction, actually alkyl halide Rx is treated with sodium alkoxide. It's treated with what? Sodium alkoxide. What is sodium alkoxide? NaOR. Sodium alkoxide. How the sodium alkoxide is formed, I'll be explaining you that. But before that, let's just understand what is the how the reaction proceed. Okay, let's understand actually the product, and in a superficial way, let's understand what is the product. Now what will happen? Understand, student. Can you identify which is going to be nucleophile? NaOR. It is going to form which bond, student? Actually, Na and OR is going to form ionic bond. N is going to give its electron to OR minus. That means N is going to become what? Na plus, and this become OR minus. So OR minus act as a nucleophile. This nucleophile is going to attack where? This is going to attack on this R. X is going to go out. What will get? Suppose I take here OR dash, right? Because here R is already there. So this ROR or R dash, where this R and R dash can be same or different. Okay, and what is more formed? NaX, right? Got that? Okay, this is called sodium alkoxide. Okay, now how sodium alkoxide is formed, right? It's very simple. Let's understand. I'm explaining that also. Alcohol is ROH, right? When this alcohol is treated with sodium, student. Okay, now we do understand ROH. Hydrogen is attached to the oxygen, right? Hydrogen is attached to the oxygen. That means this hydrogen is acidic hydrogen. I hope you know what is acidic hydrogen. Acidic hydrogen is that hydrogen which is attached to the electronegative atom, like oxygen, halogen, fluorine, right? Okay, so or nitrogen also. So this is acidic hydrogen. Acidic hydrogen has a tendency to come out as H plus. So when come out as what? RO minus plus H plus, right? If I take 2 moles of this, so obviously I get 2 mole of this, and this 2 hydrogen will combine to form what? H2. Okay, so I can write here H2. Okay, and it is going to give what? RO minus. This is called sodium alkoxide. This is what called sodium alkoxide. I can write here 2H plus. No need to write because I'm showing negative charge. It has to be positive charge over here. Okay. So this is alkoxide, and this alkoxide will react with alkyl halide to form what? Ether. Let's understand with one example. Suppose I take C2H5Cl, ethyl chloride. I treat this with what? I treat this with NaOCH3, sodium methoxide, right? I hit this. This is going to attack, and this chlorine comes out. So what I get? C2H5OCH3 plus NaCl, right? Okay, this is called what? Ethyl methyl ether. This is ethyl methyl ether, student. Okay, so this is how we are going we formed what? Ether. Okay, right? Now in the same manner there's a formation of ester. Okay, formation of ester, right? Now when this reaction takes place, let's understand. What I treat alkyl halide with silver salt of acid, carboxylic acid. Now we know what is carboxylic acid. What is carboxylic acid? CH3COH is carboxylic acid. If I replace this H is also acidic, can be easily replaced. So if I replace this H by Ag, it is called silver salt of acid. It is called silver salt of acid, right, student? Okay, so when I treat this with a silver salt of acid, like AgOOCCH3. Okay, and now when I hit this, right, this Ag is going to combine with what? This Ag is going to combine with X, and it results in the formation of RCOR. This is nothing but ester, right? And we get AgX. I'll be explaining this one example. Suppose I take C2H5, let's take Br this time. And what is carboxylic acid, student? Carboxylic acid can be written as RCOR if I open it. So can I write like this? C double bond O, I take here CH3O, and I write here Ag. RCOOR, right? Okay. Now, what is going to be acting as a nucleophile? So in this whole part will act as a nucleophile. That means it is going to acquire negative charge. Okay, so this is going to attack over here, and this Br come out, AgBr will combine, and here RCOR and this C2H5. Okay, so C2 H5 C C2H5O C double bond O, and this will become CH3, right? Okay, so what can you name this? This is called ethyl acetate. This is called what? Ethyl acetate, right? Ethyl acetate. Student, we write the name of that alkyl group which is attached to the oxygen. So we have to name this first. So this is ethyl and this whole group is acetate, and that's why ethyl acetate. Okay. So we have completed, student, substitution reaction. Next reaction will be elimination reaction, and this will be doing in next lecture. So for today we stop. Thanks for watching.